I now welcome Dr. Stephen Griffiths, Senior Vice President for Research and Development at Khalifa University, to moderate the audience Q&A panel discussion with this session's four presenters.
Good day, everyone, and welcome to the panel portion of Session 4 of the 5th International Rain Enhancement Forum. We've just seen four great presentations, and as you can tell, we're going to tap into a broad range of expertise in the panel section to think about ways to advance the field of rainfall enhancement, particularly focusing on innovations and new insights that we can gain from our panelists. So we're a little bit behind schedule, and we'll keep the questions short because of this. I would like to start off just by following on Ricardo. Ricardo, your work and what you discussed was quite interesting with regard to modeling. You talked about how convection happens over the UAE. Can you explain ways in which your insights from the modeling can be used to actually help with the forecasting and prediction of seedable clouds? You didn't really get into that too much. I thought we might start off with a discussion with you about this. We'll get Ricardo when he's back on stage. We'll start with Diana. We'll start with you for a discussion of the modeling work. So Diana, again, very interesting work you've done with modeling. You started off by going through what you've done so far with the work and finished off by talking about where the modeling work may be headed with regard to impacts from climate change. Can you say a little bit about how climate change may influence your work in the future? I think this is a question that's interesting for many people that are following the weather research modeling domain.
So based on the latest reports from the ICCP, we can see, for example, that for arid regions, the climate change will be very pronounced in the future. Although some studies are pointing out to the occurrence of more rain over these areas, but on the other hand, the temperature will be extremes as well. So, and since convection and the occurrence of convection and rain involve both of these parameters, I think we need actually to assess how our models are able to represent this under different scenarios. But in order to achieve that, we need first to be able to simulate the current time. What are the situation, the conditions during our present days, and enhance the capabilities of our models to at least represent accurately and reasonably the conditions that we are witnessing in, let's say, in the last 2 decades, let's say. So we can later use them to do projections.
We'll go to Linda, though. I think the technology work that's been done and discussed in the panel is quite important for innovation. Linda did a really nice job in the presentation of talking about her cold cloud seeding materials. Thought that was quite novel. Linda, I know you've also worked on warm cloud seeding. Can you say a little bit about where the state of that work is and what you've been doing to progress that for utilization by an organization that's now doing cloud seeding?
Okay, yeah. For this project, can you hear me? Okay, here?
Yes, very well.
Can you hear me? Yes. Yeah, it's a delay. I found there is some delay. That's probably. Yeah, the project I worked in the first cycle, including both warm cloud seeding materials and the cold cloud seeding materials. So far, the project has been finished and the warm cloud seeding materials has been nicely scaled up into production, still in a pilot case, like few hundred kilograms, and NCM with the other partners in overseas in US to testing the field experiments, field operations. Due to the delay of the pandemic, so there is a slowdown, but eventually we will have opportunities to see the results. And for the cold cloud seeding, as I said today, well, it's still in the scientific stage.
Do you have any estimation how long the cold cloud seeding material development may take to get to, say, the stage where you're thinking about scaling it up?
Yeah, yes, there is a major difference of the cold cloud and the warm cloud. Say the warm cloud material has a very specific use which is for warm cloud seeding. But this cold cloud seeding material seems has a more broad application like hail suppression, and also snow making. So I see this is a more interesting material as well, but it will span from only cloud seeding to something more. Okay.
Thank you, Linda. Martin, interesting presentation. And as I said, we'll focus a little bit more on the technological things that you've been doing. In your work, looking at the electrostatics and clouds, I found that interesting. It's something that we don't think about every day. You talked a lot about how there's a lot of work that's been done and you make good progress, but you didn't really draw a conclusion or what you think is the conclusion about the potential for electrical interactions in clouds to stimulate rainfall. So where do you think your work will ultimately go toward being useful and relevant to the organizations that are looking at cloud seeding for practical application? Can you say something about that?
So yes, thanks for the question. So I think there might be two sort of directions that you could identify. The first one is the direct injection of charge into drop populations at the stage, so that's at the lower cloud boundary, typically where the collision and coalescence process is only just starting to become active. And the charge is projected to help increase the conversion rate from drops to from cloud drops to rain by several percent over the lifetime of the drop population. So it would be as a direct seeding agent. It could be quite easily applied, and some of we haven't planned any test flights on that yet. But it's because it's the apparatus is quite compact. It can be easily incorporated in current seeding aircraft operational aircraft. And the second line, as I alluded to a little bit in the talk, was this idea that as soon as, certainly in warm cloud seeding, that the hygroscopicity of seeding material goes back when the aerosol gets hydrated more and more. We envision that charging up of such drops and aerosol will actually maintain the hygroscopicity, because one of the complex electrostatic interaction between drops and aerosols is that it's dominated by, at close range by image charge interactions, which are always attractive, and so that will produce the required hygroscopic effect at any size or at any salt concentration or whatever. So that is something that I'm seeing might be the future, where electrification of seeding material will aid the hygroscopicity of the material further down in the process. So not just at the initial stage of the process of attracting water vapor to the seeding material, but also later on when the drops are being formed.
You also talked a lot about the role of dust, because dust, of course, accumulates charges, and that's having an impact on the types of things you'd be seeing. Do you believe that your work is going to be very regionally specific, where there's some places of the world, the Middle East, for instance, that have very high dust concentrations, having different levels of impact on the effect of the electrical interactions that you can possibly stimulate?
Well, I think that must be true, yes. And this is exactly the reason why we're, of course, doing this project, trying to sort of get a handle on the different electrical environments in the UAE and other parts of the world that we have done measurements already. I mean, it's clear that the UAE, the environment of dust, is very highly electrified, and it does change the perspective a little bit on seeding with charged material. So, for example, one of the outcomes of the modeling work is that there is a potential for, if there's a high concentration of charged dust, it would make the drop spectrum too small, and the charging would actually help to keep the drop spectrum small. So in that sense, it would lead to a suppression of larger drop formation and rain formation. But having said that, I've also mentioned that the UAVs can inject charge of either polarity in the environment, and it's perfectly possible if the environment is highly charged of one polarity, we can extract that charge and thus mitigate for the suppressing effect of charge in those kind of environments. So it's very environment specific, and we expect, and because the UAE is such a it has all the highly charged aerosol and dust in the environment, it's a much more complex situation, and it's very clear that rather more work is needed to sort of disentangle the two, the kind of the suppression effect due to charge, but also the enhancement effect due to charge, which happens in different circumstances.
And taking that thought over to that,
much more complex environment.
And well, taking that thought over to Diana, you talked quite a bit about dust in your presentation. I thought that was fascinating. Can such work as Martin's with the electrical interactions, the impacts of dust, be brought into the types of modeling work you're doing, or is that something that would take some time to build into the types of frameworks you've been working with?
It would be actually very interesting to combine both, yes. I believe based on the previous studies, especially on the dust over Africa, for example, where the electrification of aerosols in the atmosphere helped to dust and also impacted other processes. So this would be very interesting to look at in the near future.
That's good. We'll look forward to that. Sounds like an exciting path forward for the modeling work. I'd like to go through and from the perspectives of both technology and modeling, hear from each of the panelists. Now, fortunately, we only have Diana to talk about modeling. Where you see the highest impact work happening in the next 5 years? In your domain, whether it's technology or modeling, what would you like to see happen in the area of rainfall enhancement, starting with Diana in the modeling world?
I would say the modeling is still a bit lacking behind technology. Many understandings have been discovered in recent years, but still are not represented in the models. So I would hope to see a lot of progress on the modeling side in the rain enhancement area.
Thank you. Linda, we'll come to you for technology. Great work on the cloud seeding material. Would you think we need more materials work, or would you go in a different direction with innovation and technology?
Yeah, at least the outcome of the field operations, evaluation of the warm cloud seeding material will provide fresh information and confirmation of the performance of this new material. I think that is a very important milestone. Looking forward to that. And for the cloud seeding material, I want to, people maybe not necessarily in the rain enhancement or weather modification, but it could be in the agricultural or the even result type of people might be interested.
No, we'll look forward to that. I know there's been not so much innovation as you showed for many years in the cloud seeding material domain. So what you're doing is quite a contribution. So thank you for that. Finally, Martin, what would you like to see? Does it have to do something with electrical interactions? Would you go some other direction with innovation?
Well, I think, as you can imagine, I would suggest to consider electrification of both drops and aerosol as a way forward. Well, so just two things. I mean, there's a technology and a science goal, of course. The science goal is continuing. We're starting a PhD project with someone working at NCM to continue on the electrical characterization of the environment. So that's something we're quite excited about. And in particular, we're interested in something that we weren't as much aware of before we started our work in the UAE, namely that there's quite a lot of fog events happening there. So we're trying to sort of do some work on that aspect as well. But I would argue, Stephen, that the ideas we have around electrification of aerosol, these are actually incredibly easy to implement in an operational sense. And so it seems probably much more easy to implement than the sort of complex materials that Linda is trying to sort of inject in the cloud. So and that she has success with at the moment. So what I suggest is that this is something that we would be amiss if we wouldn't try this out. the prospects are very good, and I think the technology is fairly straightforward.
Well, I appreciate that, and I'm always happy to see people supporting their own work and promoting it, and I agree with you, there could be great things that happen. Unfortunately, this is all we have time for today, so I'd like to once again thank our panelists, excellent presentations, great contributions during the panel session. We thank you for that. And to all the guests, we'll look forward to seeing you in the next session. Thank you.